ESR means early stage researcher, and we early stage researcher just recently finished our master degrees and are at the beginning of our research career in the beginning of first years of the PhD. In contrast, there are more experienced researchers such as postdocs or professors. HDMM means heavy-duty mobile machinery, so there are two aspects. The mobility, they are able to change their location by themselves. Sometimes they need to do it also to fulfill their work task, which is the second aspect, the heavy-duty task. They need a lot of power, force, or speed to fulfill a task. And examples are excavators, wheel loaders, or telehandlers.
Automating wheel loaders has several benefits. For example, you can increase the productivity, and that means you can move more material in less time, but you can also reduce the fuel efficiency of the machine. And another important aspect is that there is currently a lack of skilled labor, and by automating the wheel loaders more, you can help fill this gap in lack of skilled labor.
There are a lot of parameters that can significantly influence the productivity of heavy-duty mobile machineries. Firstly, the goals of working cycle can be a fundamental parameter in the productivity estimation. For example, we cannot use the productivity excavator in the loading operation for the trenching or grading operation. Secondly, there are other parameters such as type of material, weather condition, human operator, that can change the productivity of the machine. After that, the management, planning, and accurate combinations of the machine in the workshop can be a major parameter in the productivity of heavy-duty mobile machineries.
By now, everybody should be aware that climate change is a serious issue we're facing, and electrification is an important measure to reduce emissions, but so far it depends on electric batteries as the power source, which have a limited capacity. If the machine is very inefficient, we can run with the battery maybe only for 2 hours before we have to recharge, but if we increase the efficiency, we can operate even up to 4 hours with the same battery or even longer.
AI is a useful tool when automating wheel loaders, since it can be very difficult to create mathematical models that are general enough to model all the behaviors between a wheel loader and all the different kinds of material that it can encounter while digging. But by using AI, we can record a lot of data from expert operators, and then we can create a computer program that learns from the recorded data to do an efficient, to automate the wheel loader.
So in general, we use 3 types of sensors, which are cameras, lidars, and radars for autonomous perception. And they have their own pros and cons. For example, camera gives us quite a lot of information about the environment, but depends on outside source for information. while LiDAR and radar give very few features, but they have their own source for information.
Firstly, the manager of project and work site can evaluate the operation based on the productivity estimation of the whole fleet. And after that, they can decrease the cost and also increase the productivity of operation by adapting the machines and operator. Secondly, the human operators can improve their skills by using the provided feedback from the performance evaluation. And finally, the provided productivity estimation approach can be utilized as a criterion to improve the autonomous heavy-duty mobile machines in the future.
While most PhD students stay for the whole time at the university, or industrial students the whole time at the company, we are somewhere in between. We have a 3 years program. In the first 9 months, we stay at the universities where we learn about the basics of scientific work and visit courses. But for the rest of the time, we stay at 2 different companies where we are in close contact with them and learn about the needs of industry and work with them.
So for any autonomous machine to navigate and operate in an environment, it's very important to have an accurate estimation of its position and orientation, and that is known as localization. And the mapping is something which enables that machine to sense the environment and have a very good estimate of the objects and landmark around the machine, which can help to position itself and like to perform further planning and like navigation thing. So the environment heavy duty mobile machine work, they are very challenging at different points, like they have uneven terrains, so and so they can't the planner methods can't be applied directly on those kind of environment, and they work in quite challenging scenario, like the huge warehouses where the visibility has a challenge, or forest, or like construction sites which is highly dynamic and like it's not very organized. So in those kind of scenario, like the usual localization and mapping methods fails. So that is why it's very challenging in such scenario.
BAGEL is an algorithm we developed. It stands for Batch Automatic Gaussian Evaluations with Longsus, BAGEL. And what it does is it creates a model of a heavy-duty machine, and with this model it is able to imagine very fast, and it can go up to 1 million steps in the time it takes to blink, basically, and then it learns how to control the machine. And after that it has done learning the control, we can actually take it and put it on a real machine, and we have seen that it has worked. I think that learning controllers as opposed to hand coding everything will be the future. In order to learn controllers with AI methods or machine learning, we need to also have models of the dynamics of the machines, and these are called digital twins sometimes. And with these models, if we implement them in the modern hardware, for example, vectorized CPU implementations or GPUs, we can simulate these models in parallel and get a lot of data for the training of the controllers. So one instance of learning controllers that we did at HIAP was to get a digital twin of a crane, and then we trained a controller that could do a circle. And it's interesting because doing a circle with a heavy machine, which is not designed for very precision control, could mean that there is a very good chance that we could expand the application of machine learning methods in ways that they work for real machines.
An automated heavy-duty machine performs a task or even part of a task that was previously performed by a human operator in very well-defined scenarios and environments. An autonomous machine, on the other hand, performs tasks that were previously performed by a human but with decision-making capability. So the key difference between automated and autonomous machines is that an automated machine does not have its own decision-making capability, whereas an autonomous machine has its own decision-making capability. So in a way, all autonomous machines are automated, but all automated machines are not autonomous. Autonomous machines are here to solve problem. One major problem that exists in the world right now is skilled labor shortage. And when there are skilled labor shortages, it means that you cannot find enough people to take jobs related to operating heavy-duty mobile machinery. So in a way, autonomous machines are here to solve a problem, and they are not going to take away jobs. Manipulation is the movement of the implements and the end effectors that enabled the heavy-duty mobile machine to either change the shape, size, form, or location of an external material. Driving, on the other hand, is when the machine moves from location A to location B to accomplish a certain task. So assistance functions or operator assistants are functions that help the human operator to perform a task in a more simplified manner. For example, traditionally the human operator must control each individual joint so that the end effector moves to a particular location. However, with operator assistance, the human operator is assisted by some form of computerized or electronic control, which helps the operator to perform the manipulation task or the driving task much more easily. This means that even low-skilled and low-experienced operators can perform traditionally difficult jobs with a heavy-duty mobile machine.
For autonomous navigation, the vehicle has to know its position in the environment and also the position of other objects with respect to itself and also the environment. For this task, we use different sensors like cameras, lidars and radars, GPS, and these sensors get negatively impacted by adverse weather, meaning more noisy data from the sensors, resulting in less reliable output from vision algorithms, and which makes the vehicle more prone to accident.
So more practically, how to build something with the least amount of money, with the least possible time, and without defined quality. So there are different metrics that can be optimized on construction site. So a user may be interested on minimizing the time to complete the building process, so the time to build something. Other may be interested on minimizing the fuel consumption. Or maybe a user can be interested on maximizing the efficiency of the machines, maybe a combination of all of them. Other metrics that can be optimized are also, for example, the numbers of heavy-duty machinery used on construction site, so used for bagging something, and, for example, also the location where to dump the material. So there is no an optimal parameter. So which is the best one typically depends also on the specification of the project. So nowadays, the movement of material in construction site is performed by humans that typically move the material on the site using machines. But these methods have some problem because some machines, some operations on construction site may require a good experience on a particularly heavy-duty machinery in order to be performed correctly. Or maybe you want to choose which is the best machine in order to perform an operation. Maybe I can choose between a smaller one or a bigger one. Which one should I select? So all this stuff are typically learned by experience by the workers. Also, another problem might be working on difficult or dangerous situations for the human. So all this problem can be solved by using autonomous heavy-duty machineries. This will bring also an increasing of efficiency. And we also want to optimize. Optimizing means do it in the best possible way. So there will be a system that selects between some machines which one should perform an operation based on some criteria defined by some user. So maybe you just select, if you want to move the material, you just select the closest machine to the material in order to move it. Not only us ESRs, but also all the industry that work with heavy-duty machineries, because we are researching very interesting topic that will bring in a long periods, in a long run, also benefit to the industry, because all the methods are novel methods that are very interesting and will bring several benefits and will increase a lot the efficiency of heavy-duty machinery on construction site.